Today I'd like to continue on with the last section of probability. So go ahead and turn in your study guides to probability 3. Now we continue with some basic rules for probability, and let's consider now rule number 9, conditional probability. Now we've already defined dependent and independent events and have seen how the probability of one event relates to the probability of the other event. Conditional probability deals with further defining dependence of events by looking at the probability of an event given that some other event occurs first. So conditional probability is denoted by the following. Notice the notation here. We have the probability of two events B and A. We separate it with a vertical line. So the above is read as the probability that B occurs given that A has already occurred. Now it's mathematically defined as probability of B given A is the probability of B and A, B intersect A, divided by the probability of A. In other words, it's the and probability of the two events divided by the given probability, the one that has already occurred. So again, the probability of B given A is equal to the probability of B intersect A divided by the probability of A. It is equal to the and probability over the given probability. Now let's take a look at example 11 here. In a recent study, it was found that the probability that a randomly selected student is a girl is 0.55. So we're going to let the event F denote the student is a female. The probability that we have a female student is equal to 0.55. Now it is also found that the probability that a randomly selected student is a girl and plays volleyball also is 0.03. So we've defined an and probability here. The probability of female and volleyball is equal to 0.03. Now if a student is female, what is the probability that she plays volleyball? We see the word if here in a probability statement, and it's very important to note that that particular word lets us know that there is a given condition. We want to find, in this case, this particular probability based on this condition. So given that we have a student that's a female, what's the chance that she plays volleyball? Once again, we let the event F be student is a female. We're going to let the event V be the student plays volleyball. And we want to find the probability that the student plays volleyball given they are a female. So if a student is female, given they are female, what's the probability that they play volleyball? Now recall, in a conditional probability setting, the probability of V given F is the and probability over the given probability. The probability of V and F divided by the probability of F. From earlier, we saw that the probability that a randomly selected student is a girl and plays volleyball, the and probability is 0.03, and the probability that the student is a female is 0.55. So if we take that and probability and divide it by the given probability, the probability that a randomly selected student plays volleyball given they're a female is equal to 0.054 repeating. Now in example 12 it says the probability that a randomly selected student plays football if they are male is 0.25. Now notice the conditional if here again. So given that we have a male student, the probability that this particular student plays football given they are male is 0.25. What is the probability that the student is male and plays football if the probability that they are male is 0.45? So we want to find a probability based on a conditional probability and a simple probability here. The probability that a student is male is 0.45. We want to find the probability that the student is male and plays football. We're going to let the event F be the student plays football. We're going to let the event and be the student is male. Now, based on our conditional probability, the probability that the student plays football, given the selected student is a male, is equal to the and probability, the probability that the student plays football and is male, divided by the probability that the student is male. So we have the and probability over the given probability. Now, we do know the conditional probability is 0.25. So we can set up an equation to solve for the and probability.